This module is the beginning of Unit 9. Because this module on the topic ANOVA is so complicated, this will be the only module in this unit. With ANOVA, well, as we talk about, it's a way to compare more than two means. And sometimes it's hard to imagine when you would need that, but we'll look at examples below where you might be interested in comparing more than two means. Before, we've talked about comparing two means by looking at their differences and graphing those and seeing if it's a normal distribution and all that using hypothesis tests. But here, as before though, the populations or the treatments come from an explanatory variable that is categorical. So that'll stay the same. For example, we compared mean sleep hours for undergraduates and graduates. That's two different means, one for undergraduates, one for graduates. In that case, the explanatory variable X is the categorical variable education program. It has two values, undergraduate and graduate. The response variable Y is quantitative, sleep hours. It would be a number. For the ANOVA test, we will have a categorical explanatory variable X with more than two values that defines more than two populations or treatments. The response variable Y will again be quantitative. For example, we could compare mean sleep hours for college freshmen, sophomores, juniors, and seniors. That's four different categories. So we need four different means. The explanatory variable is college class. It has four values, freshman, sophomore, junior, and senior. The response variable is quantitative, the number of sleep hours. This idea is represented in the diagram below that we'll see. We'll scroll down and look at it so we can make a few notes about it before we talk more about it specifically. So note the following with this diagram. So this diagram, we're imagining that we're comparing K values or K populations, where K could be any positive number, 1, 2, 3, 4, on, and who knows, just some finite number, not infinite, of course. But the dot, dot, dot indicates that. So there's a population 1, population 2, and then up to however many populations you want. In this example, we'd have 4, the one about the freshman, sophomore, junior, senior classes. But each one of them would have their own mean. So we'd call population 1's mean mu1, population 2's mean mu2, all the way up to whatever the largest number is, K. So in this case, this example above, it would be 4. So mu sub 4 for population 4. And then sample sizes would be N1 for population 1, sample size of population 2 is N2, and on all the way till the kth one, whatever that is, the fourth one or fifth one, whatever it happens to be, will be N sub K. So let's make a few notes about this. First, the explanatory variable X can have many values, i.e. there can be many populations or treatments. 2 is the response variable Y is quantitative. Each population or treatment will have its own mean mu. From each population, we will collect a random sample. Therefore, the samples will be independent. In the case of an experiment, individuals will be randomly assigned to treatments to create independent groups. Fourth, the sample sizes can be different. That's why they don't use the same N for all of these down here. They use N1, N2, they could all be different numbers. For example, from population 2, the random sample has N2 individuals in it, and this might be different than the sample collected from population 3. So it could be that N2 is not equal to N3. The number of people in one sample from one population might be different from the number of people from a sample from another population. So we'll look at now another example. Is academic frustration related to major? I would say yes, but that's just me. College dean believes that students with different majors may experience different levels of academic frustration. Random samples of size 35 of business, English, mathematics, and psychology majors are asked to rate their level of academic frustration on a scale of 1, which would be the lowest level of frustration, to 20, the highest level. Examining the relationship between the explanatory variable major X, which is qualitative, categorical, and response variable frustration level Y, which will be a number, so it's quantitative, amounts to comparing the mean frustration levels. That sounds funny, huh? But there are 4 populations here because those are the 4 majors: business, English, math, psychology. So there's the mean frustration level from one population, mu1, from the second population, mu2, from the third, mu3, from the fourth, mu4, among the 4 majors. The figure below highlights what we mentioned previously. One, that the explanatory variable X has 4 values and creates the 4 populations: business majors, English majors, mathematics majors, and psychology majors. Also, the response variable Y is quantitative. Frustration level is on a scale of 1 to 20. So each population will have a different mu that'll be a number between 1 and 20. the average of the people from that major's frustration level. Thirdly, from each population, we will collect a random sample. Therefore, the samples will be independent. Fourth, and lastly, the sample sizes can be different, but in this situation, the sample sizes are the same. N equals 35 in each sample, but it would be no problem if they were different sizes. We could still do what we're going to describe as the ANOVA idea. And actually, I don't think we really defined ANOVA. So we talked about it kind of how it's different than what we've seen before, where we were just comparing two mu's, but this new hypothesis test is called analysis of variance. That's abbreviated ANOVA. I guess the AN from analysis, the O from of, and the VA from variance. Analysis of variance. So that's what ANOVA stands for. It sounds like something from astronomy or something, but no, it's just an abbreviation for analysis of variance. Anyway, sorry. I should have said that earlier, but now we kind of have context, so maybe now it's makes more sense. So we pointed out those four things. Now let's look down at these. So N equals 35. The sample size of business majors is 35. Sample size of English majors, same. Math majors, same. All 35. If they were different sizes, though, we would still be able to do our analysis that we'll describe. But these two examples on this page just kind of give you an idea of why or when you might want to compare more than two means. You know, here both examples had 4 means, but sometimes it could be 3, it could be 5, it could be more.